Okay, so I'm here with the second video of differentiation, which will explain you the chain rule, product rule, and the quotient rule. Yeah, three main important parts of the concept differentiation. So chain rule, there's actually two methods of doing the chain rule, but you usually write the chain rule like this: dy over dx equals, actually the variables here I've used y, x, and u. These can change, but the whole idea of this is, so here you can observe the dy and dy cancelling off, and you're left with dy over dx. So that's a chain rule. So that's how you write the chain rule, but there are two methods of doing it. So one method which I prefer the most is this. So if in the example I've shown here, y equals 1 over 9 minus x squared. So as I explained you in the first video, what you have to first do is write everything as a power of something, and it's easier if you can write it in one line instead of as fractions. So if I simplify this, it would be 9 minus x to the power minus 2, because I bring the power up, and that will be the negative power. So this is y, and I want to find the derivative of this. So I want to differentiate y with respect to x. So one method of doing this, and the method I prefer, is simply bringing minus 2. Okay, I'll use a different color here for you guys to see the change. So I'll bring the minus 2 to the front. That's the first step. So minus 2, and then I'll write the function just like that, 9 minus x. And yes, as I explained in the first video, reduce the power by 1. So minus 2 minus 1 will be minus 3. And then you put the multiplication sign, and you're going to differentiate inside the function. Inside the brackets, there is a function, right? So you are going to differentiate that function. So just 9 minus x. So if you differentiate 9 minus x, so constant, if you differentiate it 0, and minus x, so there is 1 here, and you bring 1 here, and you bring the 1 to the front, and 1 x to the power 0, so it's basically just minus 1. So that will be into minus 1, so that's, I write it down here, so that's 2, 9 minus x minus 3. That's one method, and yes, the best method, I should say. And the second method, which follows the chain rule definition, is this, which I will explain now. So you have dy over du and du over dx. So you have to find these two separately, and then substitute it to this equation, and then find dy over dx. So I'm gonna let my u be u be 9 minus x, the function inside. So that's the whole purpose. That's how you start this. This is method 2, and this is method 1. That's how you actually start this method, by defining u, or maybe you can use a or anything, but commonly use letter is u. So you have to let u be the function inside the brackets. So if u is 9 minus x, y will be equal to what? So y will be then equal to u to the power minus 2, right? Okay, so then you can find dy over du. This is also an easy method, but you had to first define y. So dy over du, simple differentiation. So that will be minus 2 u to the power minus 3. Yeah, and then you can find, oh, so you have this, right? So you found dy over du. Wait, my bad, this is du, because you differentiated with respect to u. And now you have dy over du, and you need dy over dx. So you can find that easily using this equation, right? because you have u and x. So you differentiate u with respect to x, and you're left with -1. Again, simple differentiation. So then you plug in these two to the equation here. So that will be, so you first write dy over du, and that's -2u minus 3 into du over dx, and that's -1. So you're left with 2u to the power -3. Always remember to replace the u with what we define u to be, okay? So you have to replace the u. So 2, what was our u? 9 minus x. So 9 minus x minus 3. So you obtain the same answer. So those are the two approaches you can use for the chain rule. So that's the easiest rule, I should say. And then moving on to the product rule. Again, not a hard one. So product rule is defined for the multiplication of two functions. Okay, so and you just plug into this definition. So how do this is you first write one function, and then you multiply it with the differentiation of the other function. Okay, notice that it's easy to remember. Remember it as you write one function and then you differentiate it, multiply with the derivative of the other function. So here and I have dv over dx here. And then you write the other function and you multiply with the derivative of the other function. So you basically write one and then write the opposite, the derivative of the other one. Okay, so what is my u and v here? So when you get used to these methods, you don't have to keep writing u, this is u, and this is v. You can straightforward differentiation, u and v, instead of writing. So since it's the beginning, I'll just write u equals 2x and then differentiate. I'll do it like this and then plug into the equation. Once you get used to it, you'll just simply write it like, hey, 2x, and then write the differentiation of that, and then you write straight, like in one line. You'll be able to write it in one line. So since it's the beginning, I'll show you all the steps. Du over dx is 2, and what's my v? 5x minus 2. So what will me by, okay, so we can be written as 5x minus 2 to the power half. Yeah, so you apply the chain rule here. So you bring the half front, and then you have 5x minus 2, and you reduce the power by 1, and then it's minus half, and then you differentiate the function inside the brackets. Okay, don't forget to do that. So you'll be left with just 5, and that's going to be 5 over 2, 5x minus 2 to the power minus half. And now you have the two you need to plug into the equation, right? So you just have to do that. So you have du over dx and you have dv over dx. This is that. So you just put it to this equation. Easy. Yeah. So you put u first, and that's 2x. And the differentiation of the other function, that's v, and that's going to be 5 over 2, 5x minus 2 to the power minus half, plus, what's my v? And that's 5x minus 2 to the power half, and you write the differentiation of u like this. So you have these two sections. Just have to simplify. So if you simplify this, you'll be left with your 5x minus 2 to the power minus half plus 2 5x minus 2 to the power half. So you can actually take the 5x minus 2 to the power minus half out, and simplify it further, but I'll leave it here because it's an easy simplification afterwards. Okay, so then moving on to the quotient rule, the last rule I will discuss in this video, and it's again another easy video, another easy rule. So this quotient rule is defined for dividing two functions. So you have u and v, and here my u will be this and v will be this entire function. So what you do is you write the function in the denominator, which is v, at the top, at the numerator first when you write the derivative, and then you multiply it with the derivative of the opposite function, the other function, which is u. Okay, and then the important thing you have to remember is this minus, and you have to always remember to start with the u. Okay, start with the v, sorry, the v, the denominator function, the function in the denominator. So you have to write that first and subtract it in this order. This order is very important, or else you might get the wrong answer. Then you write v and the differentiation of u, the derivative of u, and then you write minus, and then you write u and the derivative of v. Very simple. And the other key thing here is you divide it by the square of the function in the denominator. Okay, so very simple. So I have u here again, I have v here. So my u, so the same steps I follow, you write u and you write v, and then you differentiate it to get the values we need to plug into the equation, which we use to define quotient rule. Okay, so which is this? Yeah. Okay, so du over dx is 3x squared. I hope it's easier now to do the differentiation of power functions because we did it in part first video. And yeah, if I'm to say that again, you take the power to the front, you write the x, and then you reduce the power by 1. Very simple. And here it's a much simpler derivative, so you just left it 2 because derivative of 2x is 2 and derivative of 1 is 0, because always a derivative of a constant is 0. Okay, so I've discussed these key concepts in the previous video, so if you missed it, do watch it. And then now you have du over dx and dv over dx, and that's all what you need to plug into the first equation, right? So the equation says you have to write v first. So what's my v? And that's 2x plus 1. Always follow that order and remember the negative sign, and remember to square the function at the denominator too. Okay, so 2x plus 1 into du over dx, which is 3x squared. So actually this method of taking u separately and v separately and finding its derivative, it's a good method because you won't miss any part of the part which you have to plug into the equation because you have everything orderly arranged. Okay, so minus, and your u is x cubed, and dv over dx, that's 2, and you have to square the function at the denominator, that's 2x plus 1, and you square it. So it's very simple here. 3x squared, 2x plus 1 minus 2x cubed, and you have 2x plus 1 squared. Again, you can take x squared out and do make it a bit more simplified, but I'll stop it there. Okay, so I hope it's clear. So it's a chain rule, a chain rule, and that's this. So do remember the definitions, the equations I used to define the product rule, the chain rule, and the quotient rule, because it's it explains the rule really well, and that's the equation you have to use to solve any differentiation question uh, which involves these rules, or if there is a really complex differentiation equation to be differentiated, you'll probably have to use these rules. So because these three rules do play a huge role in finding derivatives, so do follow this method. And thank you for watching, and don't forget to subscribe. Thank you.